G'day, Bruce here, Barking Dog Bim, and welcome to another edition of Scripting Adventure. Now, in the previous videos, I've covered door examples that I've done in the past, along with how to create doors, custom leaves, and custom door handles using either the create from floor plan or the save as method, where you model what you need and essentially save it as fixed geometry. You can also use the library part maker if you've got the correct subscription. Now, I did these previous videos to lay the foundation for all of the functionality that you need to embed into a door to get it to respond to all the different views and circumstances you use doors in. However, starting now, we're going to get into the fun stuff. A fully parametric door using GDL. I'm going to keep the same door design, the same door geometry, so that you can easily compare the benefits of having a GDL door over your save as method. And you'll see that even though there's more work up front, really once you got it done, there's no contest. GDL all the way. We're just going to create the same door. This is my floor plan with the morph and walls and slab, etc. And remember that the door is lying face down on the floor. So we are looking at the inside face. So that means left and right are flipped. To confirm that, the high side is on the right as we're looking at it. In the external view of the door, the high side's on the left. Right, let's create a new object. I might add a GDL library parts toolbar. It's this button here, new object. I could go under File, Libraries and Objects, New Object. I'll restore down with this button up here. To show you the parameters real quick, we've only got 6 parameters there. And now when I choose a subtype, the subtype will be model element opening, wall opening, door wall. I'll fill out the details and let's have a look at the parameters. Now that I've chosen the door subtype, there's a whole bunch of parameters that come with it, but it won't give me everything that I need. So let's create some extra ones. For our door frame, frame thick goes in the depth of the wall. So frame thick is this way, frame width is that way, as you're looking at an elevation of the door. So frame thick, frame width, fine. We'll create a parameter for the radius, which will be this radius here. In this case, this will be 250. We've got leaf thickness, we'll leave it at 40 for now, and then change your attributes and pens to suit. I'll create more parameters as I go, as I need them. Sometimes it's hard to know what these are for, so I just add a little bit more of a description to help the user understand, and me, what the pen will be used for. Okay, so I've just put in some building material parameters, some surface parameters and the capacity to override those. I'll need to deal with those in the code. There's enough here to get started at least, so I'll save my object. This time I'm going to save it to an external location. Save it to my project library. Okay. If I have a look at my scripts, there's nothing in here. But let's place it in a wall anyway. If I select my door tool, the door I've just created will be pre-selected, ready to go. Let's place it using our standard methods. I've cut a WALLHOLE. If I have a look at my door here, my A width is 1 meter, my height is 2.1, my ZZYZX is hidden, it's not used indoors. These are the default values. 1 meter, 2.1. Have a look at my 3D. Let's cut a WALLHOLE. In case you're wondering what this material in here, this surface in here comes from, it's the edge material of the wall. Even though it's not active, that's what it will read. There we go. So that's how that's controlled. Okay, so it's pretty rudimentary at the moment. I'm just going to copy in some starter code. This is stuff I've developed over time to help get my thinking going with the scripting. And just until I get my 2D script sorted, I'll put in a project to command so we can see what we've done. Put in my first transformation to correct the orientation of the door. Now, I'm following on from video 21, which I'll link up there. So I'm not going to retread old ground. And I'll also put in a call axes so that I can get a handle on where things are oriented. Let's also put in a GS resolve parameter. Seeing as I'll be doing curves, I'll want to control the resolution. I'll just start that with a default value of 16. Create a subroutine. First of all, we'll set the attributes. Let's just pop this out so that I can read it a bit better. So this sets our building material and our surface. So the surface will come with the building material, but we also have the option to override that with what we've chosen for our surface. We'll set the pen for the outline, which will be the uncut pen. In this case, it'll be my plan pen, which will be the same as my uncut pen. And I want to set my cut pen as well, which when you're using building materials, you set that with the section attributes to command. And the cut pen, it says contour, but it'll actually be the cut pen. Contour pen of your cut body, and that's GS frame pen. Yeah, GS frame pen, frame cut pen. So I'll set our attributes first. I also need a couple of user parameters to control this distance here, from there to there, which I'll make the same on both sides, and also this distance there, which I'll make different on both sides. I also want parameters to control this indicator light and the indicator surround. So this is the boring part of the process where you're setting all this stuff up. So building material, override and surface for the indicator light. So we'll have the option to turn the indicator light on or off. Now these sizes I don't want the user to have control over. So I'll just create some variables in the master script. Remembering that GDL length units are in meters. So I like to write them out with the 3 decimal places to make it easier to read as meters. Now this will be the height above there. So this angle here is 45 degrees. Let's make this width fixed as well. All right. We've got our frame width. We'll just make it frame width by 2. We'll go frame base width equals, what is it? GS frame width by 2. I want the user to be able to set these heights here and here. So we'll create a couple of parameters for that. Should be before the indicator. You can always resort these, but let's do this. Frame step. Now remember, as we're looking at it, it's reversed. So as we see on the left, that'll be the right. So frame step right. $1,200 on the left. Let's call it 600. Half of that on the right. Okay. I think I'm ready to create my wall hole. Goodness, that took a while. So this is just the setup of the part before I've really done any scripting. So yes, GDL does take longer up front, but in my opinion, it's so worth it. Time to create my wall hole. What does a wall hole need? I'll open my help under help, online resources, GDL reference guide. that will open an online PDF version, or I can go to gdl.graphisoft.com and click on the reference guide, and that'll give me the online version. My preference is to download the PDF version and open it in my own viewer. And I'll just search for WALLHOLE. Right, so it's under Doors and Windows, WALLHOLE, which is under Miscellaneous, Doors and Windows. Down there, WALLHOLE. Right. So what do I need for my WALLHOLE? WALLHOLE number of coordinate lines, status, X and a Y and a mask for each of my coordinate lines, and an optional X, Y, and Z. What does that mean? N is a number of polygon nodes. Status is 1, use the attributes of the body, or 2 is generate cut polygons will be treated as normal polygons. So we've encountered this sort of language before under our cut plane tutorial, which is episode 30, and I'll link that up there as well. So X1, Y1, it's a polygon coordinates similar to a prism. Mask, similar to the cut poly A, which is similar to the prism command. So I'll cover those in a minute, but basically that's just drawing the edges or not. And XYZ is an optional direction vector. So if we leave this blank, it'll just be a perpendicular cut through the wall. Otherwise we can skew it so it goes through the wall at an angle. So if you leave them out, you're just perpendicular. So a couple of things to point out. It cuts it with an infinite tube, which just for practical purposes just means it cuts all the way through the wall. It's not going to cut part way through the wall. You'll use a wall niche for that purpose. You can use more than one WALLHOLE if you need to make quite a complicated outline for your door. And once you start using a WALLHOLE, Archicad will no longer automatically put the hole in the wall for you. Righto, so let's do this. The anchor point for my door is centered in the opening here. We'll go anti-clockwise around that way, back down again. Let's just do that. We go WALLHOLE, number. What have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. And it should close automatically. 14. Status. We're just going to use a status of 1. So we'll use the attributes of the body. I'll get rid of these and start typing. So this is 0, 0 here. So in the X, we want it to be A divided by 2 plus, let's just pop out this window so I can have a look at my parameters at the same time. Pop out my master script as well. So I created that variable. I don't think I'll need that. I'll just use GS frame width. So A2 plus GS frame width. In the Y it will be 0, and we'll need a mask of 15. Where does that 15 come from? It says here the mask is similar to the cut poly A command, and you can see in the PDF I get a hyperlink, so I click on that. Cut poly, it says it's also got a X, Y1 and mask. So let's have a look here. Mask is similar to the prism command, so let's go to there. S1, Y1, S1. So it's not called a mask here, it's called a status. So let's go to status codes for details. And we've got J1, J2, J3. And if you've been watching any of my videos, you will have seen me cover these. And so what it is, these are a side view of the polygon you're generating. This is whether it's showing a surface or not. So if it's hatched in, it's generating the surface. If it's not hatched in, it's an invisible surface. And these are the lines it generates around that surface. So this is the first edge generated, and this is the tail edge generated. And you'll see that even with all lines, it doesn't generate the tail edge because that's picked up by the next edge or the next surface you code. So we want top and bottom line and the leading line. So we'll use status code of 15. So we're down at that corner. So then we copy this line. So X, A2, GS frame width, we want to come up this distance here, which is our frame step left, which will take us to that point minus the width because it's a 45-degree angle. Frame step L in the Y minus GS frame width. Just get rid of these spaces so I'm consistent. So now we're here. Now we want to come back to just A2, which will be on this line here. This is A divided by 2. We want to go frame step L and 15. That's that point there. Then we want to come to this point, which will be B. So B is the height from here up to here. I'll make this little indicator surround poke higher than my B. And then we want to take off this curve, B minus jam radius, jam R, and 15. Now we're doing the curve part. So that will be A divided by 2 minus jam R. So A divided by 2 minus that radius. Y will be B. And then this is when we use a different status code. We want that curve through there. Just like if we were drawing a polyline. We've started here, gone up to here. Here's my pet palette with its options. Just on the straight edge here. We're drawing it to there. Now I want to use this option. Arc tangential to previous segment. And if I click on that, you can see how my arc's behaving. And if I click on that line, I get the right curve. So that's the status code I'm after. Arc tangential to the last polyline node. And under additional status codes, we've got our different polyline behaviors here for the prism or the outline that we're drawing. And this is the one we want. We've drawn a polyline, then we want it to be tangential to that and finish at a coordinate, XY coordinate. So that is status code 1000. So it's not this one. This one's defining that one. It's this one, tangential arc to endpoint. If I look at it online, it might be a bit easier to see. Tangential arc to endpoint. So I need to put in my X coordinate, my Y coordinate, 1000 plus S. So this is 1000 plus 15. I could also just write that as 1015. So that's that point there. And we go to that point, which is a master script. That was indicator width. So in the X, it's indicator width divided by 2 will be at B, and it's going to be a hard edge of 15. Then it's that X position minus the height. Because it's 45 degrees, it's the same in both directions, and it'll be B plus indicator height. Again, a hard edge. So I've got my X, got my Y, got my 15. So that's this point here. Then we've got to come back and do it in reverse. So it'll be this line, but that will be minus indicator width plus indicator height. Then it'll be minus indicator width divided by 2. Now, if I want to make this a little bit clearer for me to read when I'm coming back, I can put in an extra carriage return there. And that just splits up my coordinate lines, which allows me to visually recognize where the coordinates belong. Makes it a bit easier when you're coming back trying to adjust things. Then this will be minus A divided by 2 plus jam radius, which will get me to that point. B, it won't be 10, 15. I'm not drawing my arc yet. Just drawing that. It'll be this line and so on. Now this one is the arc down to there. It's minus A2 and it's frame step right. Minus A2 minus frame width, frame step right, and then we come down to our last one, minus A2, 15, no comma on the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14, 1. Will that work? Let's have a look. Script is okay. We'll save it. Let's have a look at my 3D. And there it is. It's fantastic. I've got the correct step on the correct side. I've got my indicator light above. My automatic hotspots will be at the bounding box of the Warhol, which is a rectangular bounding box based on these dimensions, and it's responded to my size difference. So if you remember this one, if it was a different size, wouldn't respond at all. And this one, if it's a different size, would squish. So these arcs aren't true. This one still stays. So see that? Excellent. Brilliant. This one is reduced in size. Those all squished up. But if this one reduces in size, they stay where they are because it's parametric. Now, the eagle-eyed amongst you would have noticed these segment lines here, and that is just a smoothing status code. And again, I've covered this in previous videos, but our smoothing code is J7, which is 64. So I'll add it to that line there, 15 plus 64, the one before my curve. Save. There it is. And looks like I'll need to add it there as well. And then coming back, I'll need to add it to the curve. Let's see what happens. Coming back, I add it to my curve, which is this one here, plus 64. Got rid of that one, so I need to add it to the line before as well. 15 plus 64. Right. So I've got my nice smooth curves happening. Excellent. That's our Warhol, and it's already looking good. It's already looking like a vast improvement over our other more rigid options. Okay, we are done with this video. Now you know how to set up your object to be a door so you can place it in a wall, and some parameters you might need to get started scripting. You also know how to cut a custom wall hole using the wall hole command, and how to smooth any curves you might have. In the next video, we're going to start scripting, modeling, programming the door proper. I'll see you there.